Welcome to section 7.5, Choosing Data Display. We're going to look at different types of graphs and how a graph can be misleading based off of how it is labeled or how it is set up. Let's go ahead and get started. Before we look at representing data, let's look at some different types of data. Our first type is qualitative data. Qualitative data, or more commonly referred to as categorical data, consists of labels or non-numerical entries that can be separated into different categories. When using qualitative data, operations such as adding or finding a mean do not make sense because, again, the data we're dealing with is non-numerical. For example, if our data was listing different types of colors, it would not make sense to find the mean for different types of colors. As an example of qualitative data, we have a question where students were surveyed and asked what their favorite fruit was. So we can see the categories are what your favorite fruit was, and then for our frequencies, how many students actually like those fruits. So we have our frequency table here, which was also converted into a histogram. Another question is, what is one other way that we could actually represent this? And another way to appropriately display different qualitative data would be a circle graph, or more commonly referred to as a pie chart. So that would be a third way that we could visually represent this data. For our second type of data, we have quantitative data. Quantitative data consists of numbers that represent counts or measurements. For this type of data, you would definitely be able to find the median or the mean for your data. Here we can see that we have a different question. We have the number of miles walked, and we have them broken into different types of measurements. So we have week 1, how many miles you walked, week 2, how many miles you walked, and so on. We have our frequency table, which is converted into a line graph. And something else that we could do with our quantitative data would be a box whisker plot. So that would be a third way that we could, again, visually represent our data. Here we see two different tables. One of our tables is the speed of a vehicle, and we have two different interstates, Interstate A versus Interstate B. Our second table has eye color, where we have different categories of eye color and the frequency of students who have that eye color. For each one of our tables, we have two questions. Is the data best identified as qualitative or quantitative data? And then what would be an appropriate way to display each? Go ahead and take a moment to think about this and write down your answers and then check back in and see how you did. All right, so for our first data table, we are definitely going to have a quantitative variable because we have the measurement or the speed of different vehicles on the interstates. Since we have two separate interstates, this would probably be a good way to do a double box and whisker plot. That way we would have a side-by-side comparison. For our second table, since we have eye color, which is definitely going to be a category, this would most likely be a qualitative variable. And a good way to kind of represent this would probably again be a circle chart or a pie chart. We also could use a histogram to represent this as well, and we would get the same kind of comparison as our pie chart. A misleading graph is a statistical graph that is not drawn appropriately. So there's something that's wrong with it. Either the labels are off, or the axes maybe don't have a consistent scale, or it's drawn inverted so things may be decreasing instead of increasing. We're going to look at a couple different graphs and see if we can identify what about the graph is misleading and how that could lead people to interpret the graph incorrectly. For our first graph, we can see that we have the named winter storms and then frequency. So in 2006, there were 6 different storms. In 2007, there were 8. In 2008, there were 5, and so on. The question is, what is wrong with this graph? If we take a closer look, we can see that the graph goes from 2008 to 2010. So the question is, what happened in 2009? Since we're omitting data there, we are definitely skewing this, and we have a misleading graph. For our second graph, we have a box and whisker plot, and we can see we could get our 5-number summary. We have a minimum of 5. We have our first quartile, second quartile, third quartile, and then our maximum value. And if I look at this graph, I would definitely say it looks like it's symmetrical. But again, if we take a closer look, we can see that the scale is not actually the same. So from 5 to 8, that's a distance of 3, and that looks like it's the same as going from 8 to 17, which is a distance of 9. So I would definitely say this has some scale issues, because again, we can see that we have a distance of 3 and then a distance of 9, and they look like they're the same when in actuality they're definitely not. For our third example, if you take a closer look at our y-axis, we can see that the values are actually decreasing instead of increasing like they normally would. So this would be an inverted graph, and we would be missing what's happening because we have the opposite effect or the inverse effect of what actually is happening. And for our final graph, if you look at our percentages, we have 21% followed by 34% followed by 45%, but the column heights don't actually represent that. So 21% being our smallest percent actually has the highest number, whereas 45% being our largest percent has the lowest column. Again, misleading information that people would interpret from this graph. All right, that does it for notes for this section. Go ahead and get started on the homework. Good luck.